Golden Gate Bridge stands as an iconic symbol of engineering and architectural excellence. Its distinctive design and unparalleled beauty have captivated people around the world. In this video, we will explore the architectural and engineering design of the Golden Gate Bridge and delve into the factors that make it visually striking and instantly recognizable. Architecturally, the Golden Gate Bridge is a masterpiece of Art Deco design. The bright orange-red color of the bridge, known as International Orange, sets it apart from other structures and adds to its visual impact. The choice of this color was not only aesthetically pleasing, but also served the practical purpose of enhancing visibility in the foggy conditions often experienced in the area. The engineering design of the Golden Gate Bridge is equally remarkable. It is a suspension bridge, a design that allows for long spans to be supported by cables suspended from vertical towers. The main span of the bridge stretches an impressive 4,200 feet or 1,280 meters across the Golden Gate Strait, making it one of the longest suspension bridges in the world. The twin towers of the bridge rise majestically, reaching a height of 746 feet or 227 meters above the water. These towers not only provide support for the suspension cables but also add to the grandeur of the structure. The graceful curve of the main cables, anchored securely into the ground, adds a sense of elegance to the bridge's profile. One of the key features that make the Golden Gate Bridge visually striking is its integration into the natural surroundings. The bridge spans the entrance to the San Francisco Bay, surrounded by the beauty of the Pacific Ocean, rolling hills, and the rugged coastline. The stunning backdrop of the city skyline and the iconic red color of the bridge create a breathtaking sight that is instantly recognizable and etched in the collective consciousness. Main challenges encountered during the construction of the Golden Gate Bridge was the treacherous marine environment. The site was subject to strong tidal currents, powerful winds, and dense fog, making it difficult to work efficiently and safely. Additionally, the bridge had to withstand the constant barrage of saltwater and harsh weather conditions. To combat these challenges, engineers implemented innovative solutions. They developed a floating scaffold system to allow workers to access hard-to-reach areas and used air compressors to remove water and debris from underwater construction sites. Deep and unstable seabed presented another obstacle. The strait's depth exceeded 100 feet in some areas, requiring engineers to employ groundbreaking construction techniques. They utilized pneumatic caissons, massive hollow structures, which were sunk to the seabed and filled with compressed air to keep water and soil out. This allowed workers to excavate the riverbed and lay the foundation for the bridge's towers. The design's flexibility and ability to distribute loads allowed the bridge to withstand the dynamic forces exerted by winds and seismic activity. Furthermore, the construction of such a large-scale project required meticulous planning and coordination. Engineers employed innovative techniques to manage the logistics of material transport, assembly, and construction scheduling. They used temporary catwalks and platforms to provide access for workers and implemented rigorous quality control measures to ensure the highest standards of construction. Suspension bridges are architectural wonders that rely on a delicate balance of engineering principles to create magnificent structures capable of spanning vast distances. The sheer span of the Golden Gate Strait, stretching over 4,200 feet or 1,280 meters, presented an immense structural challenge. The massive cables supporting the bridge were constructed from thousands of individual wires, meticulously intertwined and anchored into the ground. The bridge employs a suspended roadway supported by massive main cables. These strands are then compacted to create massive cables that can bear immense loads. The cables are anchored securely at each end of the bridge, transmitting the weight and force to anchorages embedded deep into the ground. Vertical suspenders, attached to the main cables, connect to the bridge's roadway and transfer the load to the cables. These suspenders act as vertical hangers, suspending the deck from the main cables and allowing for the distribution of forces throughout the structure. The result is a system that efficiently carries the weight and loads across the span, providing strength, stability, and structural integrity. To counteract the sway caused by wind and seismic activity, the Golden Gate Bridge features massive towers that rise high above the water. These towers provide additional support to the main cables and help resist the lateral forces acting on the bridge. They are carefully designed to withstand these forces while maintaining their structural integrity. The engineering challenges posed by seismic activity were a critical aspect of the design and construction of the Golden Gate Bridge. Located in the seismically active region of California, the bridge had to be engineered to withstand the forces unleashed during earthquakes. Seismic activity presents unique challenges to the structural integrity of a bridge. The ground motions generated by earthquakes exert dynamic forces on the bridge, subjecting it to shaking, lateral forces, and vertical accelerations. To ensure the bridge's resilience, engineers implemented a range of measures. One of the primary considerations was the selection of appropriate materials. The bridge's steel structure was designed to be flexible, allowing it to absorb and dissipate seismic energy. The use of high-strength steel and innovative construction techniques helped enhance its resistance to earthquake forces. Another key aspect was the incorporation of dampers and shock absorbers. These devices were strategically placed within the bridge's structure to mitigate the effects of seismic forces. Dampers help dissipate energy and reduce vibrations, thereby safeguarding the bridge against potential damage. The foundation design of the bridge was another crucial engineering consideration. Deep pile foundations were employed to ensure stability and resistance to ground shaking. The piles were embedded deeply into the bedrock, providing a solid anchor for the bridge's towers and helping to distribute seismic loads effectively. Extensive modeling and analysis techniques were employed to simulate the effects of seismic activity. Engineers used sophisticated computer simulations and studied historical seismic data to understand the potential behavior of the bridge during an earthquake. This knowledge guided the design process and enabled engineers to make informed decisions regarding the bridge's structural components. The Golden Gate Bridge holds not only architectural and engineering significance, but also a rich historical context that has had a profound impact on San Francisco and the entire region. The construction of the Golden Gate Bridge began in 1933 and was completed in 1937. At the time, the bridge was an ambitious project that aimed to connect the city of San Francisco to Marin County across the Golden Gate Strait. The completion of the bridge had a transformative effect on the region's transportation infrastructure. Prior to its construction, transportation between San Francisco and the North Bay was primarily reliant on ferry services. The Golden Gate Bridge provided a vital link, facilitating the movement of people, goods, and services between these areas in a more efficient and convenient manner. The bridge's historical significance extends beyond its transportation impact. During the Great Depression, the construction of the Golden Gate Bridge provided jobs to thousands of workers, offering them a source of income and hope during challenging economic times. It served as a symbol of progress and resilience, representing the determination and spirit of the people. Today, the Golden Gate Bridge stands as an iconic landmark and a globally recognized symbol of San Francisco. It has become an integral part of the city's identity and serves as a major tourist attraction, drawing millions of visitors each year. The bridge's stunning beauty, with its vibrant red-orange color contrasting against the backdrop of the Pacific Ocean and the city skyline, has made it an enduring symbol of the city's allure. Moreover, the Golden Gate Bridge has played a pivotal role in the development of the surrounding areas. It facilitated urban expansion and the growth of communities in Marin County, opening up opportunities for residential and commercial development. The bridge's accessibility has also fostered economic development, allowing for increased trade and tourism in the region. The ongoing maintenance efforts of the Golden Gate Bridge are paramount in ensuring its longevity, safety, and continued functionality. As an iconic structure exposed to the harsh marine environment and the elements, the bridge requires meticulous care and preservation. One of the primary maintenance strategies employed for the bridge is a robust corrosion protection system. The steel components of the bridge are regularly inspected, cleaned, and treated with specialized coatings to protect against corrosion. The coatings act as a barrier, preventing moisture and corrosive agents from reaching the underlying steel surfaces. Regular inspection and maintenance of these coatings are conducted to ensure their effectiveness. In addition to external maintenance, internal inspection and preservation efforts are crucial. The bridge's hollow structures, such as the towers and suspender ropes, are inspected for signs of corrosion or damage. As one of the most recognized and photographed landmarks in the world, the Golden Gate Bridge draws millions of tourists each year. Visitors are enthralled by its stunning beauty, iconic design, and breathtaking views. The bridge's vibrant red-orange color against the backdrop of the Pacific Ocean and the city skyline creates a mesmerizing sight that has become synonymous with San Francisco's allure. The Golden Gate Bridge serves as a gateway to the city, welcoming visitors and serving as their first impression of San Francisco. Its majestic presence and unique architecture make it an instantly recognizable symbol of the city, evoking a sense of wonder and awe. The bridge's grandeur and structural excellence leave a lasting impression on tourists, often becoming a highlight of their visit. Moreover, the Golden Gate Bridge holds significance beyond its role as a tourist attraction. It has become an emblem of American engineering prowess and innovation, representing the nation's commitment to pushing boundaries and achieving great feats. As an icon of the United States, the bridge symbolizes progress, ambition, and the spirit of human ingenuity. The bridge's symbolic value extends to its representation of San Francisco's identity. It is a source of civic pride, embodying the city's progressive and artistic nature. The bridge serves as a cultural symbol, featured in countless works of literature, film, and art, further solidifying its place in the hearts and minds of both residents and visitors. The Golden Gate Bridge, an engineering marvel and an iconic symbol, has stood as a testament to human achievement for over 8 decades. As we look toward the future, there are exciting possibilities for potential developments and improvements that can further enhance the bridge's functionality, sustainability, and resilience. One area of future development lies in incorporating advanced technologies to enhance the bridge's operational efficiency and safety. Intelligent monitoring systems could be implemented to gather real-time data on various aspects of the bridge, including structural health, traffic patterns, and weather conditions. This data could enable more effective maintenance and prompt response to potential issues, ensuring the bridge's long-term integrity. Sustainability measures could also be a focus for future developments. The installation of renewable energy systems, such as solar panels or wind turbines, could help generate clean energy to power the bridge's operations. Additionally, advanced materials with improved durability and resistance to corrosion could be explored, reducing maintenance needs and extending the lifespan of the structure. In terms of traffic management, the integration of smart transportation systems could help optimize traffic flow and reduce congestion. Intelligent traffic monitoring, variable speed limits, and real-time information systems could improve efficiency and enhance the overall travel experience for bridge users. Furthermore, there is potential for the bridge to become a hub for public amenities and green spaces. Integration of pedestrian and cycling paths, along with dedicated recreational areas, could encourage active transportation and promote healthier lifestyles. The addition of observation decks or viewing platforms could offer visitors an elevated experience and unparalleled vistas of the surrounding landscape. It is important to note that any future developments should be undertaken with great care to preserve the bridge's historic and architectural integrity. Balancing modernization and preservation will be crucial to maintain the iconic status of the Golden Gate Bridge. Thank you so much for watching this video. If you enjoyed this video, make sure to hit that subscribe button and turn on the notification bell so you never miss an update. Also, remember to give us a like so we can continue making content that you love.